So let's get started. So is 3, 9 a solution to y equals 5x minus 6? And then same thing, is it a solution to y is greater than 5x minus 6? So what we're going to do is know that this is x and this is y, and plug it in. So let's see here. We got is 9 equal to, and that's the question, is it equal to 5 times 3 minus 6? Is that true or false? And yeah, you get 15 minus 6, so that's true. Therefore, it is a solution. Okay, so yes, is a solution justified because we get a true. Here we have same idea, but it's 9 greater than. Now, is this true or false?
False.
Is this true or false?
It's false.
This is false. Yeah, 9 is not bigger than 9. So this is not a solution. No, not a solution. By the way, I should say the answer here is yes or no. So it would be yes, it is because it's true, and no, it's not because it's false. I don't want you just to put true or false. Actually answer the question, is it the solution, yes or no? And this is something you do basically on every problem. Like before you shade, you want to check a point to see if it actually works. Number 2. So let's do this by just the inequality. What can we eliminate just based upon the inequality here? So C and D because
No, B.
okay, well this is a dashed line. So these two, how about C and A? Those are both solid lines, so it can't be that. And the last two, the only difference here is the y-intercept. It says the y-intercept is -3, right here. It says the y-intercept is -2, which is the correct one. So you get B. And then you can also confirm, okay, the slope is 3/5, and that is a dashed line and shaded above. So lots of clues here to help you out. Slope, y-intercept, solid line, dashed line, a little bit of everything. On to 3, write the inequality. Okay, so what inequality is this if it's solid and shaded below?
It's the left entering.
And then the y-intercept is -2. It's looking right here. We got an x. What's the slope here? -1/1, which we usually simplify. We don't write that as a final answer. So your final answer will be -x minus 2. So y is less than or equal to -x minus 2. And don't forget to simplify. Any fraction can be simplified, simplify it. And if it's 1, drop it off. If it's -1, just make sure the negative sign's there. Okay.
How do you go with like on top of
So there's a chart that we made. Kind of look like this. So these two are solid. Solid and dashed. And these are both shaded below. And these are shaded above. So that's how you can. And the solid dash is pretty straightforward. Just means the points on the line are a solution or not. The shading up and down, just think, well, down is where the smaller numbers are. These are all negative. Up is where the bigger numbers are. So less than will be smaller numbers. Down, bigger numbers. Up. So you should have this mid-memory so you know where it goes, but it should make intuitive sense when you look at a graph as well. And the exception to this rule right here is over here when you don't have a slope, you don't have a y-intercept, the only thing you can work with is x variable, so you have to talk about x. And it goes through 5. Now, is this a less than or equal to, greater than equal to, when it's shaded over here? So are these numbers, and we're talking about the x values, are they less than 5 or greater than 5? Yeah, 4, 3, 2, 1, those are all less than 5. And it's a dashed line, so it's just strictly less than. So it's left and right when you're dealing with the vertical line. It's the same idea. The small numbers are to the left. That's why less than is shaded left. So more than just memorizing left is shaded is less than. That's just actually less than is where the smaller numbers are. Okay. Solve the system. Now, what does this mean? Okay. That's the coordinate of intersection. So, solving the system or find the solution is where these two lines run into each other. So here we go. Let me solve first one in red. Graph that. 4. 1, 2, 3, 4. Down 2, right 1. Solid or dashed? Solid. Well, they're equations, right? So they're all equations are solid. Please use a straight edge. Always, always, always. Okay. And right here, -2. And then up 4, right 1. There we can see that where they intersect. Alright, so there's our solution. 1, 2. Now, the nice thing about this test is that you can check all your answers. So before you move on, you know algebraically if this is right or wrong. So plug 1, 2 into both. Does 2 equal -2 times 1 plus 4? And does 2 equal 4 times 1 minus 2? You gotta do both. So on here we get -2 plus 4, which is 2. So that's true. Here we'll get 4 minus 2, which is 2. So yeah, it is true for both. You should do this regardless if it tells you or not. That way when you turn in your test, you know whether you got it right or wrong. You know the grade on it before you turn it in. Pretty much all of these have a check that you can perform. Okay. Number 6. Just extra practice. So down 3, right 1. 1, 2, 1, 2, 3. And start at 5. 1, 2, 3, 4, 5. Up 1 over 2, and you can see where they intersect. And I will tell you for these, they will intersect at integers. They're not going to intersect like somewhere like in the middle right here where you couldn't tell a fraction or decimal. So if you don't get that, assume something's wrong on your paper. That you maybe forgot a negative or something. And of course, when we come back from break, we'll look at, well, what do you do if they really do intersect at that fraction? How would you find that exact fraction? Alright, so we're going to go with the hypothesis that this is the intersection, which would be 2, 1, 2, 3, 1, 2, 3, 4. Is that right?
Yeah.
Yeah, -4. So that's the kind of stuff that drives you crazy. Is that you know you graphed it right, but then when you go to do the check, you miss one negative. Like you know that's -4, but you didn't write it down, and then when you do the check, it doesn't work. So just because the check doesn't come out right, it doesn't mean the graph's wrong. You might have forgotten one little detail. So when in doubt and things aren't checking out right, always look for negatives first. Always look for mistakes with negatives. That's usually where they come. All right, plug into both. -4. Do you have to show all this work? Yes, that's why I'm showing you. So we have -6 plus 2, which is -4. And we have half of 2 is 1. 1 minus 5, -4. So yeah, both graphically and algebraically the answers are the same. So we're good to go. Okay, let's do an inequality on number 7. It's not in slope-intercept form. I have to check that. However, you could just use some intercepts, graph by intercepts, because you see 3 and 4 going to 12. This is what we did when we did the word problem last week, the 7-Eleven, boomers and all that. So think of it like it's $3 for, a soda, $4 for a hot dog or something. You can spend no more than $12. Kind of the same idea. So either way, any way you want to graph it. Let's see here. So I'm going to graph by intercepts actually. Okay. So meaning plug in 0 for x, what do you get for y? Okay. So if this is 0 here, 4 times what is 12? You get 3. And then do the opposite. Find the other intercept. Plug in 0 for y. So 3 times what is 12? And you get 4. So 0, 3, and, whoops, wrong one. 0, 3, and 4, 0. There we go. Solid or dashed?
Yes.
Dashed. Okay. And shaded up or shaded down?
Up.
Up. Okay. Now, my advice to you is before you actually do the shading and you spend all that time shading, pick a point that you think is in the shaded region and check it. So let's say we want to shade up. So I'd pick, how about this? And don't pick anything on the line. Pick something actually in the shading. So this would be, what, 0, 1, 0, 1, 2, 3, 4. 0, 4. And see if it works. So if I plug it in here, 0, that'll just be 0. And then 4 times 4 is 16. Is 16 bigger than 12? 16 greater than 12, is that true? And yes, it is true. So you know that 0, 4 is the solution. And because it's true, you know for sure that this is the side that should be shaded. Then go ahead and do the shading, only after you've checked. Try not to shade too close to a dashed line. If it's too dark, I wouldn't be able to tell it's a dashed line if you're shading right up to the line. So just make it obvious. Doesn't have to, I'm not going to mark you off. You don't make it, super beautiful. Picasso.
The solution is a 5, 1, and 1.
Let's see here. 5, 1. That's in the shade area, and so that would work. So if you plug it in, 5 would be 15 plus 4 times 1 would be 4. Is that bigger than 12?
Yeah.
Yep, it's true. So any of these are answers. Anything in the shaded region, because they all give you something true. And then a non-solution would be like 0, 0. It's not in the shaded region. If you plug that in, you'll get 0 is greater than 12, which is false. That's why it's not a solution. So solutions are all true, and non-solutions are all false. So here, you have many, many different possible answers. Because how many total answers are there here? There's infinite. There's not only just the points here, but all the fractions in between. All of them will be bigger than 12 if you plug it in. Infinite number of answers. Okay. Do some more practice. Go through this one a little bit faster. And I'm going to stick with the intercepts. If you wanted to add 2x and divide by 5, that's fine. But when I see that these two coefficients, negative 2 and 5, divide evenly into 10, it's kind of easier just to plug in zeros. Okay. So we have what? If you plug 0 into here, you'll have 5 times what is 10. And that's 2. And you plug 0 into here, negative 2 times what is positive 10. You get negative 5. And then plot those two, 0, 2, y-intercept. And negative 5, 1, 2, 3, 4, 5, x-intercept. Solid line, shaded below. But just to make sure, okay, we're saying shaded below, right? So let's see, 0, 0. Is 0 less than or equal to 10? That's true. So yeah, 0, 0 is a solution, which means that's the side that should be shaded. Plug in the point, do the check, and then do the shading. Just in case this comes out false, you won't want to have all this shaded and have to erase it. Non-solution, just plug in something up here. 1, 2, this is 3, so 0, 4, or anything over here. I'm just picking, I like things with zeros, it just seems to be easier to do the check. So when you plug it in here, you can see you get 4 times 5 is 20, and is 20 less than or equal to 10? No, it's not. So that's why it's not shaded.
On the x and y chart or whatever, why do you put 2 next to it? Or why do you put both of them next to 0?
I just plug in 0 and I see what I get for the other one. So I plugged in 0 for x, and then I have 5 times what is 10, so I got 2. Plugged in 0 for y, negative 2 times what is 10, that'd be negative 5.
Okay.
Or, if you wanted to, like I mentioned before, you could do this another way. You know, Common Core is all about, well, how can I do this a different way? You know, show me 2 ways to find slope. Show me 3 ways to do this. So we could go through all this work. You can see it's a lot more work. And find out it's y less than or equal to 2/5 x plus 2. And then go up to, okay, y-intercept and up to right 5. It still gets you the same line, but it's just more work, more writing. But either way, it's not wrong or right. Same. Alright, let's do some graphing of inequalities. Where do the graphs overlap? I'm sorry, where do the shading overlap? So when we go to inequalities, it's about where the shading overlaps, not where the equations overlap, the lines themselves. Okay, so I'll do the first one in red. Gotta know that this is negative 2, right 1. So I'm going to start at positive 3, go down to right 1. This is a dashed line. Now the difference here is that I'm not going to shade anything. Mentally you're going to say this is less than, okay, that's all this. But in your final answer, this whole area is not going to be shaded. But mentally you're thinking this. Okay, it's everything below. Go ahead and do the next one. Alright, -2. And this is down 1, right 3. Down 1, right 3. And this is a solid line. There. Okay. And here it's shaded above. Right? Greater than, that's above. So what of these 4 regions, 1, 2, 3, and 4, is below the red but above the blue? What's below the red and above the blue?
1.
1. Alright, and if before you say, yeah, that's for sure, take a point, let's say 0, 0, and check it. Is 0 less than 3? Yep, it's true. And is 0 greater than or equal to -2? Yeah, so for sure this is what I should shade. I don't want you picking one, shading it, and then doing part B and realizing, oh, that's false. That doesn't work. It's too much erasing. So check it first. Actually, you check it twice. 2 checks, shade once. So check here, check twice, shade once. And what would happen if you did shade the wrong one? Okay, so if I did pick 1, 2, 3, like this one over here, I should get false for one of them. Over here, I should get, if I pick this one, I'll get false for one of them. Over here, if I pick this, I get false for both. That's why you always check both of them. Never just check one. So we got 0, 0 as a solution. And then we can do 1, 2, 3. How about 3, 0 as a non-solution? And again, I just personally like to use zeros for the solutions, non-solutions, because they're easier to plug in and check.
Sorry, I didn't understand how you did it.
So right here, it's below the red line, down from the red line, and above the blue line.
Okay.
So it has to be, both of those have to be true. This is the only region that's below the red but above the blue. Over here, this would be above. If this was it, the signs would be have to be this: greater than and greater than and equal to. If this was the answer, this one would have been less than, and this one would have to be less than or equal to. And if this was the right answer, it'd be above the red, that'd be greater than, but below the blue. So I'm just really just looking at those signs to know which ones I should be. Okay. 10. Graph this. Y, what kind of line is this? Y is less than -2. Solid, but it's horizontal. Slope is 0, right? X is greater than 3. Dotted. Vertical line. So you can tell we're kind of keen on having these graphs where you have one solid and one vertical. One vertical, one horizontal. So which of these coordinates, if you picked a random coordinate, the coordinate would be, the x would be bigger than 3, but the y would be less than 2. Yep.
Bottom right.
Bottom right. And then check it. So 1, 2, 3, 4, 5. 1, 2, 3. So you check that. So is 5 is the x, so is 5 greater than 3? Yes. And is -3 less than or equal to -2? Yes. let's go on to 11.
Thank you.
More of the same thing. Oh, wait a minute, we forgot to do, describe this in words. Part B. Describe that in words. So, how would you describe all these solutions? A good way to start it would be, this is all the coordinates and you say something like, with x's greater than 3, and y is less than or equal to 2, negative 2. So this shaded, you're describing the solution. That's all these points. How would you describe every single one of these points in the shaded? All of them, if you found the coordinate, the x coordinate would be bigger than 3, and the y coordinate would be negative 2 or smaller. Okay. Go through just one more time. Negative 5, 1, 2, 3, 4, 5. And up to right 3. And dash line. And mentally, I know this is greater than. So that's going to be everything above. That's shaded above. So definitely nothing will be shaded below. There'll be something up here. All right. And x, once again, you got to know that's a vertical line at 2. And this is less than or equal to, so that's everything to the left. So what is above the blue line and left of the red line? Okay, that's all of this right here. So pick a point, such as 0, 0. And say, is 0 bigger than negative 5? That's true. And is 0 less than or equal to 2? That's true. Yeah, so that's all of these. Okay. And then, once again, describing words. Use the same language as the last one. All coordinates that are greater than this line and less than or equal to 2. And the last two are very closely related. Describe the type of solutions for the system. So these have the same slope. What is that? And different y-intercepts. So what kind of lines are those? Visually, what do they look like? Parallel. Yeah, see? Those are parallel. And if the solution is positive 6, negative 4, if the solution is where they intersect and the two lines don't intersect, that means there is no solution. And then over here, if you wanted to see what this was graphically, get 2y equals negative 4x plus 2. Divide everything by 2. We get y equals negative 2x plus 1. Dividing everything by 2 here. And you can see the two different equations are actually the same exact line, which means they have the same slope and the same y-intercept, because they're the same line. So how many times will these two intersect? Yeah, infinitely. So if you graph this, there's one line, and there's another line right on top of it, which means they're going to intersect everywhere, infinite number of times. So that's a review, but also there's that word problem from last week. that you want to study for, there'll be something similar to that as well on the test.